Howdy math fans, it's test 15 lesson 4. Grab your swords and let's go. Today we're going to combine parts to make improper fractions and mixed numbers, and we're going to identify possible outcomes and their probabilities. Let's start out by combining parts to make improper fractions and mixed numbers. So this question asks me what fraction is shaded and answer as an improper fraction and a mixed number. So the first thing I'm going to do is figure out the improper fraction, and I'll start by finding the denominator. So remember, the denominator tells me how many parts are in one whole. So how many parts are in one whole? Well, 1, 2, 3, 4, 5, 6. If I look at these as pies, each whole pie has 6 pieces, so my improper fraction will have a denominator of 6. How many pieces are colored in? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 pieces are shaded, so my improper fraction of what fraction is shaded is 10 out of 6. Rewriting that as a mixed number, there's 2 ways I can do it. One is by counting. So if I'm just going to switch colors here because you can't see red on red. If I fill in this space with this guy, and then I fill in this space with this guy and this space with this guy, that would give me one whole piece shaded in, and 1, 2, 3, 4 other pieces shaded in. Of course, my denominator is 6 because the denominator tells me how many pieces are in the whole. The other way I can do that is by looking at my mixed number. So how many groups of 6 are in 10? 1. How many leftovers will there be? 10 minus 6 is 4. 1 and 4, 6. Same answer. And these are, of course, all equivalent. So you've done that before, so that shouldn't have been too tricky. Let's move on to number 2, which is identifying possible outcomes and their probabilities. So this question asks me to construct a table demonstrating the probabilities of rolling 2 dice, one 10-sided and one 6-sided, and getting each possible positive difference as a result. So here's all the possible differences I could get. The biggest difference is going to be 9, because I can roll a 10 on the 10-sided die and a 1 on the 6-sided die. That would give me a difference of 9. The smallest is 0, because if I roll a 6 on both dice, then I would have a difference of 0. So what I'm going to do is make tally marks to show how many different ways this could happen. So the first thing I could do is I could roll a 10 and a 6. I'm just going to start with that. So 10 minus 6 is 4. Then I could roll a 10 and a 5. 10 minus 5 is 5. A 10 and a 4. 10 minus 4 is 6. 10 minus 3 is 7. 10 minus 2 is 8. 10 minus 1 is 9. Those are all the possible outcomes if I roll a 10. So let's see what happens if I roll a 9. So I could roll a 9 and a 6. 9 minus 6 is 3. I could roll 9 and 5. 9 minus 5 is 4. 9 and 4, which would give me a difference of 5. 9 and 3, which would give me a difference of 6. 9 and 2 would be 7. 9 and 1 would be 8. That's all the possibilities with the 9. If I rolled an 8, I could get 8 minus 6 is 2. 8 minus 5 is 3. 8 minus 4 is 4. 8 minus 3 is 5. 8 minus 2 is 6. 8 minus 1 is 7. If I roll a 7, I could get 7 minus 6 is 1, 7 minus 5 is 2, 7 minus 4 is 3, 7 minus 3 is 4, 7 minus 2 is 5, 7 minus 1 is 6. If I roll a 6, I could get 6 minus 6 is 0. I could get 6 minus 5 is 1. I could get 6 minus 4 is 2. 6 minus 3 is 3. 6 minus 2 is 4. 6 minus 1 is 5. That part is really easy. Now it's going to get a little complicated. So if I keep going, I could roll a 5 on that orange die and a 6 on the white die. I can't do 5 minus 6, so I'm not going to do anything there. 5 minus 5 would be 0. 5 minus 4 would be 1. 5 minus 3 would be 2. 5 minus 2 would be 3. And 5 minus 1 would be 4. If I roll 4, then I can't use the 6 or the 5. but I can do 4 minus 4 is 0, 4 minus 3 is 1, 4 minus 2 is 2, 4 minus 1 is 3. And if I roll a 3, I can do 3 minus 3 is 0, 3 minus 2 is 1, 3 minus 1 is 2. If I roll a 2, I can do 2 minus 2 is 0, and then I can do 2 minus 1 is 1. If I roll 1, I can do 1 minus 1 is 0. Now that's assuming that you have to subtract the number on the white die from the number on the red die. If I can do it the other way, I would have to go through now and start again with the white die and say, for example, if I rolled a 6 on the white die, I could do 6 minus 4. I could go through that whole thing again. I'm not going to because that will take a really long time. Instead, I'm just going to, those are all the possible outcomes, and I'm just going to find the probability now. So I just have to count up 5, 10, 15, 20, 25, 30, 31, 32, 33, 34, 35. There's 4 here, so 35 plus 4 is 39, 40, 41, 42, 43, 44, 45. There's 45 possible outcomes. So my chance of getting 0 is 6 out of 45. My chance of getting 1 is 6 out of 45. My chance of getting 2 is 6 out of 45. My chance of getting 3 is 6 out of 45. My chance of getting 4 is 6 out of 45. My chance of getting 5 is only 5 out of 45. My chance of getting 6 is 4 out of 45. My chance of getting 7 is 3 out of 45. Chance of getting 8 is 2 out of 45. And my chance of getting 9 is only, 1 out of 45. I was going to write a 9 there. So that's what a probability table looks like. So here's your review for today. Number 1, write an improper fraction and a mixed number to show what portion of the circles below are shaded. And number 2, create a table to show the probabilities of each sum you could get rolling 2 4-sided dice. So sum means adding the numbers together. Write each probability as a fraction. If that seems confusing, I would back up the video about 5 minutes and watch that first problem that I worked through with you again. Have a good night. See you tomorrow.